Standing by for launch command.
A lot of the ideas that we're working on have never been even thought of yet. We came up with an idea of a 3D printed satellite, and I'm constantly thinking about how to make this lighter and stronger at the same time. The entire satellite cannot weigh anything more than 100 kilograms. Eating up the biggest portion is large batteries, computers, all the parts that go in it. Just to make it a satellite that can function in space takes up a lot of the weight.
The whole concept is that you should be able to build a platform that services multiple industries, multiple customers, multiple countries, multiple companies, as opposed to just being focused on one particular industry with one particular sensor. So you're not sending up, hundreds of satellites focused on different things. Instead, it's one satellite that can service many.
Every ounce matters, and it's not only just making things to hold the payloads, it's changing the structure itself. The more weight I bring out, the more payloads we can put in, which gives us the advantage by 3D printing everything. I can make changes on the fly, and it goes into the next structure.
We're designing LizzieSat for a 5-year life, and so we want to make sure that our material is going to last that long, so we continue to support our customers that entire time.
A satellite has to be really strong. It's got to take 5G load and launch. 5Gs it's basically 5 times the weight of gravity. If something weighs 5 pounds on the inside, it's going to weigh 25 pounds at launch. If it weighs 100 pounds, it's going to weigh 500 pounds at launch. When it gets into space, it has to take a lot of solar radiation. And then there's the temperature swings. On one side of the Earth, we have the sun. The other side, we have the shade. So the temperature swings are anywhere between 300 degrees Fahrenheit, 200 Celsius. There are numerous specifications to make sure that what we're putting on the rocket is actually going to be able to go through the launch, be deployed into space, and perform as it's expected.
How does Markforged live up to that?
We actually received a grant to build a flight test platform. It's the beginning stages of a satellite, so you were able to send that up to the International Space Station for a while and then bring it back down and test those materials.
So we rapid prototyped the sample holders out of onyx, and we put them in this experiment and went up into space. This went up, and as you can notice the degradation, because it was white, but the sun degraded it so much being out in a space environment, and all of the onyx parts, no degradation whatsoever. There's no difference between a part that's just come off a machine and what's been out in space for a year. I think everyone was surprised by it. I believe that everybody thought that when the parts came back, there was going to be total degrade of the material. I believe some people thought that it wouldn't even have lasted through the entire experimental process. The Markforged material took all the punishment and came back looking just like the day we printed it. It was perfect.
It was on the outside of the ISS for a year. That wasn't the original intent. It was supposed to be like 15 weeks. It was outside for a year, came back down, and that material's great, and it's intact. And so we know that it can survive. And that's why we're excited about having Markforged as the base for LizzieSat.
We're using continuous carbon fiber throughout the entire structure. It gives it strength similar to aluminum. If we were to use aluminum and we had to make a change that would take a considerable amount of time just to get the design change made and then manufactured and put together, you couldn't produce something as fast as when you're 3D printing. With what we're doing right now, if something changes, I can reprint it, and in a day I can have brand new parts.
Markforged is just, it's so economical, and the speed at which we can manufacture a satellite bus is unbelievable as well.
See you later. It's not only making the parts so they're able to print, it's also making the parts so I'm using the least amount of material so they still pass analyticals. Not a lot of people think about how much a screw weighs, and if I could remove those screws from the assembly and somehow rapid prototype a fastening feature, I'd take that weight out of it. This part right here, it falls into the slot and then locks into place. And when it's bolted in place, now it's not going anywhere, no matter what you try. And this keeps our entire satellite structure together. You can't pull it apart because the design on the inside is so precise. If it was off by a few thousandths of an inch, it would easily come apart. 10,000ths of an inch off. It's less than paper thin. Yeah. It's like, yeah, cut it down. Yeah, exactly. And there's no way that you could possibly machine this feature. You could machine this end, but this end here, you could never machine. But it works flawlessly every time, and it's because of the tolerances. They're just perfect. We're starting to print everything with Onyx FR, fire retardant material, and we're also using Onyx FRA. The A designation gives us the traceability of the material, which is required by numerous companies. Traceability tells exactly where the material was made, so they can follow it all the way back. You get a crack, you get a shear, something happens that the analysis says it wouldn't, they could find out how the material was made and find out where the error was, correct the error, so the next time we get the material, it'll work. I've been 3D printing for at least 25 years now. So many 3D printers, you buy materials, one day it's like this, the next day it's like this, and you're trying to figure out, what am I doing wrong with your parts? Whenever I'm printing with Onyx, every single part comes out exactly as it's supposed to. There's no unknowns. I know exactly what I'm going to get, and it's working. It's working very well.
I don't think we would be doing this if it wasn't for Markforged, honestly. The idea of LizzieSat came out of that flight test platform, and it came out of using those materials. We've created this flexible model that we can put any technology we want in there and service, customers, whatever their needs might be.
7, 6, 4, 3, 2.
Launch day will be a really big day for not only me, but for everyone. Each project is different, and each one of these is an adventure because it's building something that's never been done yet. Once this one launches, I'll be looking forward to the next adventure.
Into the deepest grandeur of our universe.